lesson 5.3. Today we're going to be talking about multiplying rational numbers. Now, when you see the term rational numbers, remember we talked about that with the number system and how each time we go to another category, it grows with what type of numbers are included. Remember, the rational number system is like the biggest one. So that means that it includes everything, including numbers that can be written as fractions or decimals. So basically, we're going to be dealing with multiplying fractions and things like that. So, when multiplying fractions, you just multiply across. So, when you're multiplying two fractions, you multiply both numerators and both denominators together. You just multiply across and solve. So, it's a little bit easier than adding fractions and subtracting fractions, because when you do that, you have to get the denominator the same. But when multiplying by fractions, you do not have to do that. So, do not worry about the denominators being the same, just multiply across, then simplify. So anytime you're writing an answer, you always want to write it in simplified form. So don't ever leave it like 4 over 20, because you know that 4 can be taken out in both the numerator and the denominator. So basically simplify, don't forget. Alright, now it's a little bit easier when you do it with just numbers, but what happens when you're doing it with variables? All variables, some variables, what do? So basically you multiply across like usual. So in this case we have x squared over 3y times z over 2x. Now, we're going to multiply straight across. So now we have x squared times z, or x squared z, and then 6xy. Now, I noticed that there is 2 x's in the numerator and 1 x in the denominator. So we can cancel that out. So basically we're taking out the greatest common factor to simplify it. So this is part of the simplifying form. So we're going to go ahead and divide out a x, and we're going to be left with xz. Instead of x squared z, we're left with xz, just 1x. xz over 6y. So that is the simplified form. Alright, now a certain term that you're going to need to know is called dimensional analysis. Now that sounds all fancy, but what does it mean? It says the process of including the units of measurement as factors when you compute. That also sounds fancy. So basically it's just you're using the units for measurement like feet, miles, minutes, seconds, anything like that, and you're going to be using them when you're dividing and multiplying and things like that. And something's going to happen to those. So they can't just all of a sudden plug a number or a unit on the end. You have to know what unit are you talking about once you do all of your computations or all of your division and multiplication and stuff like that. So let me show you what that looks like. So basically, in this example, 760 miles in 1 hour, or 760 miles per hour, times 1/4 of an hour. Now, how do these units come into play when you're multiplying and dividing with rational numbers? Now, in this case, we have our numerator and our denominators, and we're going to multiply across. But there's something that I see first. Now, in this case, this is talking about hours, and here's hours here. So since this is in the denominator, and this is kind of talking about this whole unit over here, you can go ahead and cancel those out. So that's exactly what I did here. I realized that if you have anything on the opposite sides, you can just cancel them out. So I'm going to do that so I don't have to worry about it at the end. So I'm going to do it now. So I'm going to cancel those out, and because I know that in the end I'm going to be talking about our distance. Now, that means we need to cancel out our time. So I'm going to go ahead and multiply across now. So 760 times 1 gives us 760, and then 4 times 1 gives us 4. So basically our hours units have been canceled out, and we're left with 760 over 4 miles, and then if you simplify that by taking out a 4, you'll be left with 190 miles. So basically that's how we go from how we use dimensional analysis and how we use the dimensions and units to be able to cancel out to be able to solve. Now let's go ahead and do some more examples. Alright, let's look at example number 1. It says 1/4 times 3/5. So this is a simple one. We're just going to practice our skill by multiplying across. So 1 times 3 gives you 3. 4 times 5 gives you 20. And since 3 does not go into 20 at all, and nothing can break down 3 anymore, it's in simplified form. So 3 over 20 is our simplified answer. Now here we go. Let's look at example number 2. We have 1/2 times -5/6. Now, there's something interesting about this. There is a negative number. So when you're multiplying fractions, just like when you're multiplying integers, you just have to, if there's one negative sign or an odd number of negative signs, your answer is going to be negative. If there's an even number of negative signs, it's going to be positive. So it's the same rules that you've used in the past, you're using them now. So So we're just going to have to put kind of two things together. So let's go ahead and multiply 1 times 5, that's going to give you 5. Then 2 times 6, which is going to give you 12. So we have 5/12. Now let's think about it. We have one negative sign. Is the answer going to be positive or negative? It's going to be negative. So we're going to go ahead and plug a negative, so it's negative 5/12. All right. Now let's deal with negative numbers and mixed numbers. So when you're dealing with mixed numbers like 5 and 1/3 and 3 and 3/8, just turn them into an improper fraction so that we can multiply across like usual. So 3 times 5 is going to give you 15, plus 1 is going to give you 16. So this is 16 over 3. It's actually negative, so negative 16 over 3 times, we have 8 times 3, which gives you 24, and then plus 3, which gives you 27. So you have 27 over 8, and that one's negative as well. So since both of our numbers are negative, we know that our final answer is going to be positive because we have two negatives, which is an even number. It's going to be positive. So now let's go ahead and multiply across. So if you multiply 16 times 27, you're going to be left with 432. And then if you multiply 3 times 8, you're going to be left with 24. And since we multiplied, both of those turned positive. So now we have a positive 432 over 24. Now let's go ahead and simplify. So if we wanted to take out a 24 out of the numerator and the denominator, we are going to be left with 18 over 1, or just 18. So all of this turns into 18. And it's positive because both of our numbers are negative. All right, let's go ahead. I know it's kind of hard to see this right here, but let's try to look at it carefully. This one we have a mixed number and a normal fraction to multiply together. So we have 3 and 1/4 times negative 2 over 11. So I'm going to just go ahead and change this to an improper fraction. So 4 times 3 gives you 12, plus 1 gives you 13. So we have 13 over 4 times a negative number, negative 2 over 11. So let's go ahead and multiply across. 13 times 2 is going to give you 26. And then 4 times 11 is going to give you 44. Now let's think about it. We have one negative sign. Is our final answer going to be positive or negative? The answer is negative. So we are going to go ahead and kind of simplify it a little bit. So let's divide by 2, because I could see they're both divisible by 2. So I'm going to divide by 2. So 26 divided by 2 is going to give you 13. And then 44 divided by 2 is going to give you 22. And I think that that is it. So our answer is negative 13 over 22. All right. Let's go ahead and deal with some examples that have variables included. Now, in this example, we have 2 over x times 3x over 7. Already, I can see that there is going to be an x in the numerator, the denominator. So I know I'm going to have to take that out eventually. So let's go ahead and multiply across. So 2 times 3 is going to give you 6 times x over 7x. So we know that these x's can be canceled out because that's our greatest common factor. It's the biggest thing that we have in common in the numerator and the denominator. We're going to go ahead and cancel those out, and we're going to be left with 6 over 7. And since both of our numbers are positive, our final answer is going to be positive as well. All right, let's go ahead and look at a little more complex version of fractions with variables. So we have 4 times t over 9 times r, and then 18r over t squared. So let's go ahead and multiply across and then simplify. So 4 times 18, let me do that over here real quick. So we have 32, and then we have 7. Okay, so we have 72 r times t over. Then we have 9 times 1, which is going to give you 9. And then we're going to have rt squared. So when looking at the numerator and the denominator, I see that we have several things in common. First of all, we can go ahead and take out a 9 out of the numerator and the denominator because we know that 9 times 1 gives you 9 and 9 times 8 gives you 72. So we know that we can take out a 9. But what else can we take out of both the numerator and the denominator? So we're going to take out anything they have in common to make it simplified. So for sure we're taking out a 9. I also see an r in common, so I'm going to take out an r. And I see that there's 2 t's in the bottom and 1 t in the top, so they share 1 t, so I'm going to take that t out as well. So we're going to take all of this out of the numerator and the denominator. So we're going to be left with, in the numerator, 8 over, and then our 9's cancel out, our r's cancel out, and one of our t's cancel out. So it's 8 over t. That is our simplified form. All right, let's go ahead and do a word problem. It says a car travels 65 miles per hour for 3½ of an hour. What is the distance traveled? Use the formula d equals rt to solve. So let's go ahead and set up our equation. So first of all, do we know the distance? No, because it says what is the distance. So we know that this is what we're going to be solving for. So let's see, what is the rate? Okay, the rate is 65 miles per hour. So when we're talking about rate, we're talking about the speed. So we have 65 miles per hour. So we have 65 miles over 1 hour. Okay, so now we're going to be multiplying that by the time. So what is the time? So it gave 3½ hours. So times 3½ of an hour. Alright, so now we are going to be using our dimensional analysis to be able to cancel out these units. So that we know that we're going to be left with at the end miles, right? Because it says what is the distance. So we know that somehow these hours are going to be canceled out, and we're going to be left with just miles. So let's go ahead and see what we need to do. First of all, I can see that these hours cancel out. Second of all, I'm going to go ahead and change this into an improper fraction. So now I have 65 miles, and since our hours have canceled out, I'm just going to put over 1. And then 2 times 3 gives you 6, plus 1 gives you 7. So times 7 over 2, and our hours have canceled out, so I no longer have units left on that number. So now let's go ahead and multiply across. So 65 times 7 is going to give you 35. 7 times 6 is going to give you 42, 43, 44, 45. So 455 miles over 2. So there is our final answer. And since our number ends in a 5 here, it doesn't go into 2 evenly, so we can't simplify anymore. So this is our final fraction. All right. Now, as always, go ahead and look back over the video if you have any questions. You can also go in your book and see some more examples. That might help you a little bit. And if you still have questions, feel free to bring them into class. I'll be happy to answer those. Now let's go ahead and do some on your own questions.
All right, you have 4 problems to do for me. Go ahead and multiply them across to be able to solve. Make sure to put them in simplified form. Now, this last one, it says blank feet is equal to 5/6 of a mile. Now, we are doing that if 1 mile is equal to 500 or 5,280 feet. Now, for this one, I do have kind of a hint for you. Your answer needs to be in feet. So the way you set up your equation, make sure your miles cancel out. Okay? So go ahead and try that one. It might be a little bit difficult, but I want to see what you get. All right, good luck, and we'll see what you get tomorrow.